Uh, Thanks, everybody, for joining in. I'm Apurva Kumar. I have been working in the ML and data infrastructure space for the past 15 years at companies like Uber, Amazon, and Walmart. And today, I'm going to present on it's an individual study that I did over the past 1 year. And the topic is on the autonomous AI agents and how to leverage those in the AI infrastructure space. Let's introduce why AI infrastructure is so important in the computing world. So it is the backbone of nearly all the AI applications that you use out there. So whether you are using a chat agent from Meta or a shopping agent from Amazon, Rufus, or you are interacting with day-to-day with any of the AI application, somewhere down the line they are using some models inside, either embedded as a service or an agent these days. That's fairly common. And so where is the gap? Traditional AI infrastructure is being heavily focused on human. It's more policy-based, and it's very human-driven. If you look at the application side, we have moved on to using AI agents a lot. But if you look at the infra side, the one that is maintained by DevOps inside your companies, you might still feel that we are not leveraging AI agents, or we might have started using it, but it's not to the full effect. And one of the key problems that some of these applications that have started leveraging AI agents in the AI infrastructure, they are focusing on bits and pieces of the infrastructure, not a holistic view. So there is definitely a research gap that is not looking at the AI infrastructure in a holistic space. And to give you a real example, this is one of the why do we need an AI agent autonomous agents in the AI infrastructure space. So one of the examples, there are numerous outages that have happened in the industry. One of them, the key one that at Amazon happened in 2017, when a DevOps, while doing a routine maintenance task, he was upgrading some server. There was a typo in the server, the query that he issued, and it took down S3 nodes from the rotation. And what happened was there was a massive outage for many hours, and it costed S&P 500 $150 million. So this was an example where something like an AI agent that does a lot of automation, that does things on its own with the rule-based or learning-based checks that can avoid those typos in the first place. So DevOps is there. There can be code reviews, but still there can be typos, and it happens now and then in the industry quite often. So that's where this study is all about, how to leverage this AI agents in this infra space. And the overall objective is not just to use them, but to make them self-managing and make them scalable and energy efficient as well. So, and I will focus on why energy is so important in AI infra. You might have already known that without we being efficient in the using of the power, it's not going to scale in the long run. And this is based out of a publication. The paper link is here in the slide. So what are AI agents? So, these are autonomous systems that basically does three things. They perceive the environment, they process information, and performs actions. So perception is they take some inputs. They take input from sensors or data or metrics that in the infrastructure space, they can look at all these different metrics of the server side, how much compute is being used, disk is being used, memory is being used. Those is the perception input. And then the decision-making layer either can have algorithms or models. We can use leverage RNN, a learning model that can make decisions for us. And the action is what the action the AI agent took. So the examples of these AI agents are quite common. They have, for the past 6 months or 1 year, they have exploded in the industry. People have been using it for different use cases, for coding-based editors, to chatbots, to recommendation system, and they are also being leveraged in autonomous vehicles also now. So why do we need AI agents in the infrastructure space? I have touched this upon in the introduction slide, but we do want our infrastructure to be more dynamic and resilient to failure. Humans are always been helping her for the past 20, 30 years in the tech industry, but it's time now to also adopt the AI agents along with the humans. So we have a DevOps community we have data engineering community, but we also need AI agents to play together with them as well. And they can help in many folds. They can do things like fault recovery pretty quickly. They can do resource optimization for us. They can do sustainability goals like allocate nodes based on the power capacity and reallocate nodes based on power needs or the energy utilization. So those are the metrics that they can take actions on. And or they can also do like real-time threat analysis. They, like instead of somebody reporting on on social media that, hey, you have a security threat and things go wrong for you, they can do real-time monitoring of the logs and see if there is perceived threat to your data or users that you are serving. And they are not going to replace humans. I mean, they are going to collaborate with the humans. That's the end goal that what like everybody wants to see. Like humans are going to be in the loop and they can be more efficient as we go. So what are the different type of AI agents? So at a broader category, there are like 5 different categories. There can be more based on different studies that are coming out. So one is the like reactive agent. Reactive agents are like, they don't have any memory. They just give immediate response. So it can be like a chess playing player. You can have a chess agent that you are playing against. They can give you a response without using much memory or very little memory. The model-based are more like they have internal states. So for example, you have a thermostat-based model that adjusts to based on some patterns, like time of the day, energy, or the temperature inside the house. Those are the things that a model-based agent you can leverage. Goal-based agents are more towards like earning at some objective. Like you're building like say last mile delivery bot for your company, and those are the example of autonomous robots. They have a goal to deliver their to go from point A to point B without being obstructed on the way. Utility-based agents are more like for like based on some utility. Like example, like they have like a business goal in mind. For example, like a financial trading system can be an example of a utility-based agent. Learning agents are more like they adapt through their past experience or historical experience. So for example, like if you are like a voice assistant, like a Siri or Alexa, that's where the learning-based agent might be more useful. So in terms of if you map these AI agents to AI infrastructure, I think like the learning-based agent have a better fit because you want to learn from the historical data as well as the real-time inference that your models are making. So those like logs, metrics, real-time logs, those are the key input that can help your model perceive and make decisions. So yeah, like choosing the right agent, there are like different dimensions that you can use it. Like one is the task complexity. Are they like simple tasks or multifaceted tasks? That is one criteria. Like, is your agent doing just one thing, or is your agent doing multiple things? Like, you can build like a tourist AI agent that can do like airline booking, bus booking, and things like that. That is like a multifaceted example. Versus just chatting, that can be like a single-faceted. Environment, like what kind of environment this AI agent is going to behave in, that is another criteria. Resources, how much memory or CPU or GPU that you are going to give, that is another choosing criteria. And the scalability, like is it serving like few users or like thousands and millions of users, that is another area that you can choose your agents on. So this is an example of like it's an illustration of an AI infrastructure that you can use in your like it can be applied in AI infrastructure space. So the middle tier is the like a manager tier. If you're looking at Kubernetes architecture, the green nodes can be in the Kubernetes managing architecture, and the orange nodes can be in the worker tier. That's where your actual containers are running. And then we have a feedback loop, which can perform like different aspects of your goals of your AI agent. It can be it can be based on the performance, it can be energy, or it can be security, based on what are you optimizing for. And at the top is your data, that is your real-time user events or any like click-through events that are coming to your system. So the core of this is the middle tier, the manager tier. That's where you're going to utilize the AI agents. And we have a decision tuning layer, the white box right there. And it takes continuous feedback from the real-time metrics and the users. That is where you can tune your models to make the optimal decision for a particular event. So like I said, real-time decision-making layer is the core of this entire system. And you can use like different type of, like for this study, I did I used a learning-based agent, I used RNN, and also had this rule-based logic as the another aspect. So I hard-coded all the rules there, like given an event, what will the Kubernetes master is going to decide? Like, is it going to do decision A versus B? And the RNN is something that I trained on a set of data. I'll talk more about that in a future slide. And the key functions that I evaluated this setup was threefold. One was the adaptive load balancing. Like you want to make sure that you are making a real-time decision on your existing, like the routing task. Like given an input event, which node you are going to send your data event to for actions. And if you have like some node failures or you have some bottlenecks, how are you going to do healing on it? And also, these agents can do elastic scaling for you, and so that you can handle unpredictable loads. And also, given we have a feedback loop on energy, we can downsize or upsize our cluster based on the energy utilization. So another aspect that I focused on was the fault recovery. So like we want to have like an automatic failure detection, so that based on like the real-time health events, we can detect our failures and do, like compared to a rule-based or human-based, it will take a lot of time. But with the AI agents detecting it in the real time, it will be much faster. They can do root cause analysis for you, reading the logs. They can do like ML-based correlation for you and enhance those logs so that it's more readable for the humans. They can do self-healing, restarting a service, rerouting a traffic. Those are the things that it can do. They can state preserve and roll back in case you encounter a rollout failure with a new, like let's say you roll out a new version of your software, it has some issues, they can do the rollbacks for you. The other goal that I focused on was the energy, like based on like different power consumptions of these different different type of compute nodes, like CPUs, GPUs, or TPUs, you can control like how much resource they are going to use. And you can do this dynamic resource scaling up and down. Similarly, you can do load shedding, you can do hardware-aware decision making. Like if you have a compute task, you can choose the right task based on the hardware that is available to you. And you can also focus on green AI principles so that your architecture is well suited for the green AI goal if your org has that in mind. So for the A/B experiment setup, like there were two groups. One is the treatment group, one is the control group. For the treatment group, I used a learning-based agents. So it's like a multi-agent environment where they are based on RNNs. And the control group is more like a rule-based, like traditional AI infrastructure that has been in industry. And the input data that I used was from the Google. Google has this open cluster workload data sets that is publicly available. So this was the input that I ran my cluster setup against. And the key metrics that I monitored was resource utilization, how much is resources I'm using, the fault recovery time, and the energy consumption. And like the outcomes were pretty promising for the agents. For example, for the rule-based, like I had like two dimensions. One is the rules, and the third was the human intervention. And if you look at the results, like using the AI agents, I found like 30% higher resource efficiency and 50% reduction in the fault recovery. So definitely AI agents have much better resource utilization compared to traditional rule-based systems that we have in place in industry right now. And they also tend to do better in terms of fault recovery. So if you have like nodes going down or you have some fatal errors, they can do quick action using the log analysis and take actions on their own or involve human in the loop. The other aspect was the energy efficiency utilization. Here also, for example, like load redistribution, putting the right load on the right node, that was another criteria. So we saw like 40% reduction in the energy cost, and we have like better, like it definitely leads to better environmental sustainability. So last but not the least, the autonomous agents are not going to replace humans. They are going to help humans, especially the DevOps, the data engineering community, or anybody who is on the in production environment. They are going to help them. And like I said, human in the loop is going to be the future. And Collaboration examples can be multifold, like agent can, for example, automate a pipeline, and human can approve the release. Agent can propose a fix. If it's like a normal fix, it can apply on its own, but if it needs like a human review, it can send it for human review. It can do like root cause analysis. It can do train the jobs, rank the jobs, and a human can adjust the priorities for those jobs. The other final aspect I want to touch on is the ethical and the regulatory considerations. AI agents need to be ethically sound, like they need to be transparent and fair in decision making. We need to introduce like bias metrics. So while we are deploying these AI agents in the infrastructure space, we need to have those metrics in place. Like example being disparate impact, which controls like racial bias or those aspects, touches on like those aspects. Allocation fairness and resource fairness index, it has to like, in a multi-region environment, you need to have like allocation fairness so that one region is not being heavily utilized and others being less utilized. So these kind of like bias metrics needs to be in place before we even deploy them in production. And last but not the least, they have to be compliant with the data protection standard because they are reading real user events in real time. They need to follow all these policies like HIPAA, GDPR, and so forth. So some of the codes that are really powerful in this space is like from one is management. So this one makes like the energy and the AI tightly coupled together. Like we cannot get enough AI in the world if we don't have enough energy. So energy has to be one of the key pillars that we should focus our next set of like AI infrastructure. And there's a study from Gartner that that in the next 5 years we'll have like 150% utilization, additional utilization in the data centers just running AI applications. And the world doesn't have that much energy right now. And then this is confirmed like Eric Smith. He has mentioned that like in the next 10 years or 5 years, we will be needing much more power than what we have right now. And this is not sustainable in the long run if we don't have energy in mind right now. So like data centers and energy, they are tightly coupled right now. And next 5 years, we should focus on solutions that are energy efficient. And I think when we deploy these AI agents in AI infrastructure, which is purely like the data centers, we should keep those things in mind, like the principles that have been discussed here. So to conclude, like autonomous AI agents will make things more dynamic and resilient in data centers. They will be making better decisions compared to humans. They will have less typos, those kind of human errors that can be overlooked because they can be trained on historical data, and they will not try to make those mistakes. And humans are going to be in the loop. They're not going to go away. I mean, they will be more efficient, 10x more efficient as a DevOps community using AI agents. And last but not the least, please fill out the survey if you like the talk. Thank you.